Hello, I'm Andrew Smith from the Open University Cisco Academy team. I'm exploring content for TM357 Cisco Network in Part 2, and we're on Module 2, cunningly OSPF configuration. Now, what we need to do is set up an ID for the router, and the ID for the router comes from many elements, and it's so that we can identify the router for a DR/BDR election and assure that whenever there is an election process that the router gets priority, or a router gets priority. Now, to configure a router, we set up a process ID, not a router ID, a process ID, because different routers can have multiple different OSPF processes running. And that way you can actually create separate router OSPF systems within a networked domain as well. So often you'll see router OSPF 1, a common configuration. It is between 1 and 65535, so it's a signed positive integer. For some reason they don't use 0, but from 1 to 65535. And you'll discover that process 1 is used. And you'll set that up as a common process within the system. You'll set up areas, you can set up whether it's going to redistribute default routes, you can set administrative distances, what networks, whether it's a passive interface that you're not going to send traffic out on, or a router ID for this process, which is at the very bottom. And of course the router ID then can set up an ID for a DR/BDR election. So if you look at the very bottom, right next to the R1 at the bottom, you can see that you can actually set up a router ID. It's a 32-bit value, but by setting that, you can actually set an order of precedence. So what happens is it usually will use the ID or a loopback address or a interface ID. So if you don't set the ID, it'll try a loopback. If you don't set a loopback, it will try the highest available IP address. And the ID is a IPv4 address, well, it's a pseudo IPv4 address, so it's not a real world address. So if you want to use 1.2.3.4, you can do so without any conflict, and it will enable that participation. And it usually goes through to see what there is. Obviously, if there's competition, it will go to the next value. If there's competition there, it will go to the next value, and so on. So here we can easily set up the ID on a loopback address, so 1111, and then we can say that the router ID is 1111 on the system. And you can actually just go in and explicitly say, so here we set it as the loopback. Here we actually say that we could actually have the router ID as 1111. And basically, if you are going to ensure that you're in control of the configuration, my advice to any student, to any network administrator, is put the router ID into the router OSPF process. If you do that, you know you're always in control. If you do that, you will never have to worry about which router is going to take precedence. And sometimes we notice that students on their assignments forget about this one. Quite useful fact. And obviously you can just go in and know it at any time, change it to another ID and control it accordingly. In point-to-point, there are two ways to set up the network command, and the network command is used to tell the OSPF process where it's going to broadcast hellos and LSAs. Now you could do it network 192.168.0.0, wildcard mask 0.0.0.255, area 1 or area 0. Okay, that will mean then that it will send out on any interface from 192.168.0.1 through to 192.168.0.254. Because obviously a wildcard mask is ones, yeah, we don't care, and zeros must match exactly. But obviously we could also say it could be on a specific interface. So it could be network 192.168.0.1, wildcard mask of 0.0.0.0, which means must match, area 0. And this is quite useful. It's the same as doing it on an interface if you learn about actually configuring OSPF on an interface. OSPF wildcard masks, the rules are exactly the same as access control list wildcard masks, where you can actually set up patterns. They are a little bit simpler here, but what you're basically saying is if it's 0, it must match. If it's 1, we don't care. We could have any combinations, which means that we could have some clever combinations if we've got a range of interface IDs on the network. Obviously, this gives a couple of simple examples of where we're matching 4 possible addresses for 0003, and we've got 256, or technically 254 possible addresses for 000255. So the patterns can be configured. And here's a great example where we're saying these exact interface IDs with 0000 are the only ones where the LSAs or the hellos are going to go out of. But if you look at the bottom of this example, so we've actually got router OSPF process 10. Well, we set up router OSPF 10, but we can then say on the specific interfaces, this is where we're going to send the advertisements. So GI000, now IP OSPF area 0. So we don't even need to do that wildcard mask or that command. We can actually just point it out of the interface and say, here is where LSAs and hellos are going to start. And then technically that is more secure, and that Packet Tracer will handle that. My view as an academic is either is good, it's whatever you want to configure in order to do it, but you need to be aware of this from a CCNA examination perspective, and especially if you're doing any of the configurations on some of our day school, virtual day school, or EMA or TMA activity. Because of the fact that OSPF automatically propagates out of all the interfaces that is within a wildcard mask on a network address, you can also tell it on certain networks, okay, if you've got a stub network that's pointing out to a switch, on here, whilst it's a learnable network, we don't want LSAs, we can actually use the passive interface and tell the process, out here we're going to send no update. That improves security, but it also reduces network traffic propagation as well. On OSPF point-to-point networks, you're not going to get a DR-BDR election process. So basically, once they realise that there is no other devices on the system, it just sets itself up as a point-to-point configuration. That's actually quite simple, and I'm actually going to show that in my configuration example after this video. Loopbacks obviously are used for ID. They can be propagated, but obviously a loopback is automatically a point-to-point system because it goes nowhere. It's a dead end, but it can be used as an ID or can be used as a routable point of interest. So do this first packet tracer point-to-point configuration activity. What's quite interesting is multi-access, which can be demonstrated through a network switch on packet tracer and most network topologies, because switches will broadcast broadcastable traffic, and obviously an LSA is a broadcast. Then there is a DR BDR election that will take place on 224005. The updates will be sent, and then there is a holdback every so often on .6 where it's just checking if it is available. So what we have to do is set these IDs accordingly, and it's best sometimes demonstrated by doing the show IP OSPF interface command, or best demonstrated sometimes by building a network and then just on packet tracer running it through a restart as well. And it's better that I configure this than rather than show you just through talking through a range of slides that you can read at any time yourself as well. But if you do the show IP OSPF neighbors or show IP OSPF topology, you will see where the sort of different DR BDR devices are actually running on that. But it's important to remember, if the DR fails and the BDR becomes the DR and the DR other becomes the BDR, if the DR comes back, it does not become the DR again. So this is where you need to set up your IP OSPF priority and actually make sure that an interface or a network or a device is likely to win the election within a network segment using DR and BDR, obviously using packet tracer. There is also the cost metric, which gives that line value. The cost metric is notional, and it's for you to tell the system what value it has, because obviously shortest path first doesn't just look at the hops, it looks at the cost of the line, and you can actually then notionally inform a line if it's too expensive or it's not a priority, and you can actually set up different cost values. There is a default cost according to the line, but you can then alter the reference bandwidth if you've got a much more preferable line. And actually, one of the packet tracer activities we do, you have to look at the auto cost reference bandwidth and see if you need to actually change the cost accordingly, to change the preferred route, to change how the shortest path first algorithm operates. And of course, that way then it can create quite interesting topologies on your network that you can manually set using that configuration. And also you can tell it to how often you're going to set out hello packets. By default they're 10 seconds, but once you've actually got an established network, why does it need to send this out so often? You can secure it. You can secure it using MD5 authentication, but you could actually control the cost. And if you've got two connections and one of them's got the wrong hello timer, that will bring the connection down as well. So once you configure the hello and dead interval timers, you've got to make sure that either side understands that it's going to be operating, whether it's faster or slower. Obviously faster, more updates, higher convergence times for failure change, lower value, slower to change, but also not so many updates taking place between different devices on the system. And of course it's modifiable on the interface, which is the point or port at which it's sending out the traffic. There is another packet tracer activity to work on that's useful for that as well. Default routes, basically you just propagate any quad zero default route in using the default information originate. But what you're probably not aware of is you've got a fixed static route. So if you do an IP route 192.168.0.0, 255.255.255.0 S000, that is then a static route, not a default route, and you actually have to do redistribute static subnets in order to propagate that as well. So default information originate for default routes or quad 0, but if it's a standard static route, you actually have to do a redistribute static subnet, and that often catches out students as well. To verify, I've mentioned a couple of these already. You've got show IP OSPF neighbor, IP protocols, IP OSPF, IP OSPF interface, but there is also show IP OSPF topology, which is quite useful, and you can easily verify and work your way through and look at all the different OSPF settings on your router, as well as a show run, a show IP interface brief, and a show IP route. Because at the end of the day, whatever the routers learn, it is going to put in the routing table, and you need to do a show IP route. And then finally, after a couple more practical activities, you'll have some more work to do on OSPF. And my advice to all students is get your hands on the packet tracer activities and do them to your heart's contentment, because there will be a lot that you will learn from these that will make module 1 mean more sense to you and prepare you for the EMAs and the TMAs, OU jargon, our inter-module assessment, and our tutor marked assessment as well. So thank you all very much. I'm Andrew Smith from the Open University.